line, because the force would be constant, so the acceleration would be constant, so the velocity would constantly decrease. But because most of the force is occurring early on when it's going fast, therefore it's going to have a greater amount of change, therefore acceleration early. So this line is steep. But later on, the line's not very steep, so the acceleration isn't very much. Remember that a velocity versus time graph, the slope is acceleration. Now, let's look at this in terms of throwing some numbers in. At t equals 0, that means that all is going to become 0. What's e to the 0? E to the 0 is 1. So that's going to be 1 times VO, so whatever the initial velocity is the velocity, and that makes sense. Let's go to the other extreme. What happens at t equals infinity? Well, if t equals infinity, then all of this becomes infinity. So that becomes e to the infinity. So as the time gets closer and closer to infinity, this is going to get closer and closer to 0. So in the theoretical world, this thing actually will never stop moving. It will get closer and closer to 0, but never actually get there. But remember, that's the theoretical world. Okay, so we ended up doing a fair amount of work, but it was cool because we ended up getting a formula for the velocity at any moment in time. Even though the acceleration is changing, we could find out what the velocity is. So now let's find out where it is. So I'm just going to write here that our goal, derive for position with time, because that's what we want. We want a formula that x is equal to blah, 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 blah. So if the integral of acceleration gave us the velocity, there's our change velocity, v minus VO, then how are we going to get from velocity to position? Well, the integral would make that an equality. So the integral of velocity will give us where it's at, the position. All right, good enough. So we have a formula for velocity. Now all we have to do is, well, I say all we have to do, not that it's that simple, but we have to integrate that. So let's set it up. So we're going to say that x, okay, and that's with respect to time, is equal to the integral of this formula up here, velocity. So that's VO e to the minus k over mt, and we're integrating with respect to time. So there's a little derivative of time. We're going to do this from time 0 to some time in the future. That's going to be 0. Okay. Now, you may have recalled that there's an integral that you can look up that's e to the u du is equal to e to the u. So if this was e to the t dt, that's a constant. We can just bring that out. Let's do that right now. Okay. Then we could do this integral very easily. It would be done in one more step. But that's not the case. So it enables us to have additional fun, because this is not e to the t, it's e to the something else t dt. So we need to get it in this form of e to the u du. So in other words, if we can make that u and this du, then we can do the integral. But until we do that, we can't do it because it's not in this form. So we're going to do a little trick here. Let's make that u. Let u equal minus k over mt. And now, if that's u, then all I need to do is get a d, replace this with a du. And if this is now a du, and that's a u, then it's in the form of e to the u du. Well, how are we going to get a du? Well, du is the derivative of u. And if we have u, let's just take the derivative of u. And what does that come out to be? That comes out to be minus k over m dt. Now, if you're having trouble with that, you need to talk to your physics teacher or your calculus teacher. That's a basic first derivative, and you better know how to do that. Okay, now we have a du, so let's get this du in there. Now, how are we going to get that du in there? Right now, this is acting like u, and let's get this du in there. Well, we can sub in for dt. So let's get dt by itself. So I'm going to bring the m over here and the k on the other side. So that's going to become dt is equal to, the m will be up top, so it's going to be m over k du, and there's a minus sign in there. I brought that minus sign over too. So now this whole thing can go in here. Now, this is not part of my integral. This is just a little trick on the side that I've used so that I can use this integral. So now we're going to sub that in. So that's x is equal to VO, TO, T final, e to the minus k over mt, and that's minus m over k du. Now, I put this in brackets because I don't want you to think it's e to the minus k over mt minus that. No, this is just a negative sign, but this is multiplied by that. Now, that's a constant, that's a constant. So right now, let's just bring it to the outside. So that's just going to be VOM over k with the minus sign, TO, T, E, and then isn't that u minus k over mt? Yeah, I made that u. If I wanted, I could write that as a u, because that is that. Or, if you want, I could also write it like this, if you like. It doesn't matter. It's the same thing. But either way that you do it, we've done our tough work. We've gotten this thing in the form of e to the u du. E to the, and that's our u, du. So now this integral does apply. So now we can do the integral. And the integral actually is the easy part. It just becomes, that's all constant stuff, so that just stays on the outside. And what is the integral? What's e to the minus k mt, which is u du? It's just e to the minus k mt. E to the minus k over mt. But don't forget, you've got, did I make a mistake somewhere? No, I'm doing okay. I'm still doing this from time initial to time final. So I think that is right. Okay, that looks good. So let's subtract it out. I'm going to actually move this over here. I don't know, that's the way I have it in my notes, but MVOK, and that's e to the minus k t over m, that's t final, minus a minus MVO over k e to the minus k t 0 over m. That's final minus initial. Initial time is 0. So does this whole thing drop out to 0? Wait just a second. You got to be careful. E to the 0 is 1. So that becomes just 1 times that, and that's plus. So that's MVO over k plus, and that's minus MVO over k e to the minus kt over m. We're doing good here. And now let's factor out an MVO over k. And I'm also going to put this, well, it doesn't really matter. I'll clean that up at the end. So it's MVO over k times e to the minus kt. It's just a little bit of algebra cleanup at this point. Plus 1. Let me put that minus sign. You know, I'm not gonna factor out the minus sign. I'm gonna leave the minus sign on the e. Okay, and then I'm going to do it like this. X is equal to, yeah, I'm just gonna move this on the other side. MVO